if you look in here in the segments, we have two segments. The size of the first segment is D7, which if we go in the Python interpreter and hit enter, it is 215. And the size of the second load segment is C, which is just 12 bytes. So 2015 plus 12, we would have 227 bytes. But we have more than 400, I think 464, as you see in here, bytes in the data, which means, as we said, because the data is classified into different segments and sections, each category would be good for one view, the execution or the linking. So in here we have 227, which means that only 227 bytes somehow are useful in the execution view or process. So we have other bytes which are not owned by any segment in here. The same happens about the sections. If you pay attention, if you want to calculate it, the size of the text section is 27, which we calculated is 39. So we have 39, and then we have the size of the data, which is 12. We have the size of this section, which is 120. 120 is hex is 288, and we have 50 and 27. So 50 would be equal to 80 bytes. So we have 80 plus 2. Again, I just want to add all the decimal values in here. So we have 239 in here, 112, 180 plus 288 plus 39 in here, plus 39 again, and then plus the C in here, which is 12. And hit enter, we have 458, while the size of it is 464. So we have 6 bytes which are not owned by any section. These bytes are called to be orphan bytes. So one last thing that I wanted to mention, which is so important, because actually the purpose of all of these couple of lectures that I've been explaining about the executables was to look at the inside of all of these sections. As we saw we look at the SHSTR tab section in the previous module, and also in the previous lecture we saw that it was the name of the other sections. We looked inside the data section, and you saw it was the hello world, which is 12 bytes. And now it's time to look at the most important section in almost any file, which is the section which contains the executable instructions. So 27 means 39 bytes are saved in the .text, which are the most important bytes. We want to have a look at it. So there is one way to look at it, and that's by looking at these bytes in the hexadecimal representation. We have B801000000BF and so on until we reach these last byte 00, which is the 39th byte. Now, one of the things, if you want to completely understand what every one of these bytes mean, one of the things is that one of the options is that you look up all of these bytes, you look at the instruction set architecture or ISA of every processor and see how different instructions have been encoded, what B8 or 01 means, and all of those things. Or we could just use some already made applications or programs like objdump, which disassemble these bytes in here. Or in other words, it just gives us the related assembly instruction to each one of these bytes. So if I go in here and just clear the screen and say objdump -m Intel, because I want to see the assembly instructions in the Intel format, -d and then the hello world, and hit enter. Now if you look, we have at the address of 4000 B0, which is the memory address, the file offset is B0 as you see in here. And then the first byte would be B8, then 01, then 3 bytes of 0, which you see exactly in here. Then at the next address, we have the 48BE and so on. Actually, let me make sure. No, actually we have B. So B8 01 000000 BF 01 and 00, as you see all of them in here. What this program does is that the same thing that we explained. It looks at the ISR of this processor and gives us the related assembly instructions, which says move ERX 0x1. What this means is that when the CPU sees these 5 bytes in here, it looks the decode and logic, the decode unit of the processor would decode it as move EAX and 0x1. So this one has been created, has been encoded using 4 bytes, which is 01000000 in the Little Indian format. And B8 in here means move ERX, whatever comes after that. BF in here means move EDI and whatever after that. So what it means is that anything that comes after the BF, I want you to move that into the EDI register. Or in here, 48 and BE means that I want the value in the memory address of whatever comes next to be fetched and put into the RSI register. And if you see, we have the memory address of 6000 and then the 8 encoded as in the Little Indian format, and the content in here would be moved into the RSI register, and well, other things that you see in here also. For example, BA means that move whatever comes next into the EDX register. Now in here you could somehow guess. If you look, we have B8 and then we would have B9, BA, BB, BC, BF and so on. Every one of these bytes have been encoded somehow that the CPU would look at them and does something specific. So BA8 means that move something in the EI register. B9 would mean something else. B8 in here, again, the EA register. BF means move in the EDI. BA means move to the EDX, and so on. Also, for the last part, if you look, 0F05 would be decoded by the decode unit or decode logic in the processor as syscall in here, which would well pass the control to the operating system.